Hey, welcome to Course 3, Saxon Math, Lesson number 2. Lesson number 2 is on the concept of orders or operations of arithmetic, and then what kind of properties and stuff we can do with that. So first, the operations of arithmetic, there are 4 basic operations that we look at. Those basic operations would be addition, subtraction, multiplication, and division. So a couple things that we can look at is the different terminology that we might have. So let me erase some of this for us. And let's look at this first one. An addend plus an addend is equal to a sum. For subtraction, the minuend minus the subtrahend equals the difference. A factor times a factor is equal to the product. And a dividend divided by divisor is equal to a quotient. So if we looked at a problem like what is the quotient when the product of 3 and 6 is divided by the sum of 3 and 6? If we were to look at that, example number 1, let's identify a couple things that we want. What is the quotient? The quotient is going to be what our final step is. When the product, I'm going to use red to underline this, the product of 3 and 6. Product means multiplication. So 3 times 6 is 18. So I can take this product of 3 and 6 and put in 18 is divided by here we got the sum of 3 and 6. The sum of 3 and 6 is 3 plus 6, which is 9. So I can remove this entire statement and say 9. So now it says, what is the quotient when the 18 is divided by the 9? So 18 divided by 9 is 2. If you have a hard time keeping them all in your head, then go ahead and write out the sentence and do exactly what I did there. Find the parts and take care of those parts. Now, another thing that we've got as we continue to look through here is in multiplication, there's different ways to write multiplication. So if I had 3 times 5, we could say that's 3 times 5. We could say that's a parenthesis 3 times 5. Sometimes we'll see a large dot, 3 times 5. And technically, you could remove one of those parentheses to show 3 times 5. And it doesn't really matter which one you remove. Oops. Doing a different property there. We could do parenthesis 3 times 5. And now it all shows multiplication. 6 divided by 2. 6 divided by 2 is a couple ways that we do it. 6 divided by 2 could be written like this. 6 divided by 2. It could be written like this. 6 divided by 2. It could be written like this. 6 divided by 2. Now, one thing we sometimes have trouble with is remembering what the order is here. Dividend divided by divisor is quotient. So if we know this is the dividend, and we know this is the divisor, we can use what we know to be able to know which one is this. Here's the dividend, here's the divisor, and in this one here, dividend is in the house, and the divisor is out there. Memorize it. One of the things I talked about in the past is how dividend is a longer word. There's more letters in dividend. It's a bigger word. If they were wrestling, dividend has the divisor pinned because it's larger. If there was a hailstorm, dividend, bigger person, kicks the little one out of the house. Not very Christian-like, but he protects himself, kicks divisor out, and here, first in line is the dividend. So if that helps, find your own tricks to help you out with that. And a variable is just that. Numbers we've looked at are constant. Constants don't change. A 3 is always worth the value of 3. But a variable is a letter or symbol that represents a certain number. So we might see variables come out. If we had 2 plus 5, that's 7, all constants. 2 plus x, x becomes a variable. So the value of this depends on what the variable x is, because the value might change. So let's look at the properties of multiplication and addition. Subtraction and division do not share these properties. So commutative property of addition. Commutative property, we see here in the beginning a CO. That CO, I like to remind you, is to change the order. So anytime I see CO, it's changing the order. So what might that look like? A plus B equals B plus A. Real numbers, 2 plus 3 equals 3 plus 2. The value there is the same. So commutative property of multiplication, here we have it again. CO, change order. So if I had A times B, letters can just be next to each other, equals B times A. 2 times 3 equals 3 times 2. 6 equals 6. The next property we have here that is similar is the associative property. Associations, or your associates, or people that you hang out with. So the associative property actually changes who you hang out with, who you associate with. So think about it as association, think about associations as your groups. The groups might change. So when we look at the associative property, if I have an A plus B plus C equals A plus B plus C, notice the order is the same. What I'm going to change is my grouping. So in here, the first one, A and B are hanging out. The second one, B and C are hanging out. So if we apply that to numbers, parenthesis 2 plus 3 plus 4 equals 2 plus 3 plus 4. If we were to simplify that, we get 5 plus 4 is 9. And here I would get 2 plus 7, which is 9. It works out. Associative property and multiplication is the same thing. So here I have A, B, C. A, B, C. Order doesn't change, but I'm going to change my groups. So in multiplication, 2 times 3 times 4 equals 2 times 3 times 4. Following those order of operations, 2 times 3 is 6 times 4, which is 24. 2 times 12, 24. So it works the same. Identity properties. The next thing we have the identity property of addition. And looks like we should have identity property. Let's change that to multiplication as well. All right. So the identity property of addition, basically identity is who you are. So when we're looking at the identity property of addition, we want our answer to be the same as our start. So what could we add to A to get A? 5 plus 0. It's the identity. We get the same thing out of it. So in multiplication, what's going to be the identity property of multiplication? What are we going to multiply to get A? A times 5 times 1. 5 times 1. Because the zero property of multiplication is something different. The zero property of multiplication states that anytime we multiply by 0, the answer is going to be 0. So A times 0 equals 0, or 5 times 0 equals 0. There's really only one more main concept that I want to share with you. And the book is going to ask you to simplify expressions justifying each step. So, for example, let's say we have 25 times, so 25 times 15 times 4. So we can simplify this in two ways, but we want to justify those steps. So if we were going to work on this, a justification is going to be, it's going to be like a proof, something you're going to be doing in geometry. So if I was going to do a proof here, my first step is always going to be given. So when you have homework and you've got to do these, this is what we're going to set up. We're going to set up this idea of given. Now everything's being multiplied, so we're going to use the multiplication properties. Now it would be a whole lot easier if we could multiply 25 and 4 rather than 25 and 15, but it's going to take us a little bit of work to get there. A mistake, I'll do this in red, that I often see is people do something like this, 25 times 4 times 15. Now, ultimately, that's what we're going to want. So I'm going to take this, and let me slide this over here. And we'll talk about why that's not our first step. So we can only change one thing when we do a proof. So we can either change the parentheses, or we can change our groups. So what I'm going to do is I'm going to take this step here. I'm going to move my parenthesis. I changed the order is the same, 25, 15, 4, but my group changed. Changing the group is the associative property of multiplication. There's my evidence. Now, my groups stayed the same, but I changed the order within the group. I can change the order based on the commutative property of multiplication. Commutative, change order. So now, (25 times 4 times 15). The order is the same as the line directly above it. What changed are my groups. So the associative property of multiplication. And now you'll notice, this is what we got. Whoa, let's undo that. This is what we've got. But it took us a couple steps. In ours, if we had this as our second step, we did the commutative property and we did the associative property. Three steps technically in one. And in a proof, we can only do one step. So now let's finish our justification. 25 times 4 is 100. And our evidence there, our justification is 25 times 4 is 100. And then here, 1500, because 100 times 15 equals 1500. When they ask you to justify the steps, that's what I'm going to want to see. Now, if you look at example in your book, example 3, they show you can do this two different ways. One, I have this one. You'll look at their second way. It's a little bit different. They use properties in a different order. As a result, less steps. Our goal is to do less steps, but I wanted to give you something different than what you see. But it's definitely easier than the first way, following order of operations. So take a look at it, see what you get. Some of the things that we're going to have also in this lesson, if you look at the next example, if we had 100 minus 365, if you remember when we add integers, we add the numbers and the signs positive. So if we had 2 plus 3, the answer is 5. A negative 2 plus negative 3, the answer is negative 5. Whoops. Trying to go too fast. But if we change the signs, 3 plus -2 or a -3 plus a 2, when the signs are different, then we do a subtraction. So 3 minus 2 is a 1. The 3 has a bigger absolute value. Here we have -3 plus 2. We again, 3 minus 2. The answer is -1. Well, that's essentially what we have here. 100 minus 365 is the same algebraic addition as this. So we would simply take 365, minus 100, get 265. Answer is negative because we're taking away the bigger number. And then we're going to have equations and expressions as well. Looking at example number 5 in your book, 6 plus x equals 30. And we may have multiplication 6 times y equals 30. My preference is for you to use the algebraic thinking, not just thinking about fact families. 6 plus x equals 30. One way we can look at it is, okay, I know it's a 30. 30 minus 6 is 24. So 6 plus 24 equals 30. That way is okay. But you guys are in higher math now. Let's play our balance game and keep it balanced on both sides. X equals 24. In this one right here, we could think fact families. We know y equals 5 because 6 times 5 is 30. But what's our evidence? Well, let's do the same thing on both sides. Divide this side and this side. Y equals 5. And with those, you can go back and double check those. You check to make sure you're accurate. 6 plus 24. I took my 24 and put it in. Equals 30. It checks. This one right here, I'll take my 5, substitute it in. 6 times 5 is 30. It works. So we've made it through the examples, made it through the practice. Go ahead and do the practice problems on your own. Pause the video, try the practice problems, see what you come up with. When you're finished, come back and take a look. Or if you get stuck, but don't lose the opportunity to think on your own. All right, let's take a look. See how you do. The first couple ask you about what property is shown. So name the property illustrated. 4 times 1 equals 4. Again, I will let you abbreviate the identity property of multiplication. Identity property of multiplication, because we multiply and we get the same thing we started with. Our next one, 4 plus 5 equals 5 plus 4. So this is an addition property. You can see that the 4 and 5 changed order. Commutative property of addition. That's all you have to put for me. Looking at the next one, 8 plus 6 is in parentheses. That'd be quantity 8 plus 6 plus 4 equals 8 plus 6 plus 4. The order does not change. So the next thing I look at is my grouping. Here's an 8 plus 6. Here's a 6 plus 4. The grouping are my associations. So the associative property of addition. Associative property of addition. And then finally, 0 times 5 equals 0. A lot of times we want to call it identity property. But this is the 0 property of multiplication. Please use those abbreviations as you do this work, and I'll be okay with that. So our next one, E, was what is the difference when the sum of 5 and 7? So here's my first problem, the sum of 5 and 7. So 5 plus 7 is 12. So I'm going to get rid of this. I'm going to write 12. Is subtracted from the product of 5 and 7. Product is multiplication. 5 times 7 is 35. So I'm going to get rid of this and get rid of this, 35. So now I can think through, what is the difference when 12 is subtracted from 35? 35 minus 12, 23. 23 should be my answer. As I keep going, F, 36 minus 87. I remember a lot of times we're told you can't subtract a larger number from a smaller. But we are better than that. 36 minus 27, 1, 5, I get 51. This is a bigger number, we're taking a bigger number away, so I get a negative 51. Now the next one is one of the proofs. Now, sometimes they're going to start you off. If they don't start you off, then I need you to write this entire thing. Start with what's given, work it out, and tell me the steps. So as I look at this line to this line, only one thing changed, and that was the order. So changing order, commutative property of multiplication. From here to here, 587, 587, order did not change. They changed my groups. That's the associative property of multiplication, changing the groups. And then we got 40 times 7, because 5 times 8 is 40. And then from here, the 40 times 7, I guess we can show you here, 5 and 8. And then it's one step each time, the answer becomes 280, but in this case, we're interested in those two properties. Which takes us to H. Left H blank, because we got to do some work here. H is asking you, how can you check a subtraction answer? So let's take that real quick. We need, by now, 8th grade, you're going to be using your vocab. So let's take 8 minus 3 is 5. So you have to find out 8, 3. What are the names of these numbers? Which one's the minuend? Which one is the subtrahend? So the 8 is the minuend. 3, subtrahend. And this is my difference. So if I were going to check to see if this is true, I would have taken 5 plus 3 is 8. So to explain how to do it, you would take the difference, add it to the subtrahend. And sometimes that's where kids stop. It's the difference added to the subtrahend, but what do we do with that? Should equal the minuend. So take a look at your problem I. Is that the way you worded your problem I, but this time with the quotient and dividend and divisor? Because it says explain how to check a division answer. If you did, continue checking. If not, go ahead and pause the video, retry, and see what you get. But 8 divided by 4 equals 2. 8's the top number. Is that the dividend, or is that the divisor? So the top number would be dividend divided by divisor equals my quotient. For me, it's a lot easier to have the visual using the words than trying to remember what we have. Now, if I was going to check this, I would take 2 times 4 equals 8. So, to check a division problem, the quotient, the answer you get, multiplied by the divisor should be equal to the dividend. So using the easier numbers, 8, 4, 2, help me to explain where my letters go. And then finally, the last two problems, J and K. If we use the math, J, 12 plus M equals 48. I would subtract 12 from both sides. M is equal to 36. Is that true? Does 12 plus 36 equal 48? Yes. So my answer, M equals 38. K. 12 times N equals 48. The Divide both sides by 12, n equals 4. This 12 times 4, 8, 4. Looks like it matches, so n equals 4. Before I let you go, there's a problem S. Looking at this one right here, 8 plus 6 plus 4 equals 6 plus 8 plus 4. We've got parentheses. What is my property? Do you have an answer? Let's take a look. 8, 6, 4, 8, 6, 8, 4. The order has changed. So inside this parenthesis, the order has changed. My group is still the same. So guys, just to be careful, just because of parentheses does not make it associative property. This would be the commutative property of addition. And I think you have that lesson. If you have any questions, contact me or go back, watch that part of the video again. Good luck on your homework. And God bless.